Hello and welcome to the BS Academy. We hope that your preparation is going well. So let's start the next video. Before that, if you are new to your academy, then please subscribe for the upcoming videos. In the heat transfer, we have completed two charts in which we have discussed about the basics, then conduction, convection and heat exchangers. The links for that are in description box. In the heat transfer, this is the final chart of the subject in which we will discuss about the radiation and some basic portion of the radiation also we have covered in the second chart. Now let's begin from that second chart. Here first one is the properties of surface emission depends on the temperature, nature, wavelength and frequency. Then here for the total emissive power, E is equal to sigma into epsilon into A into T raised to 4 into W. Here for black body emissivity is equal to 1 and for grey body emissivity is equal to 0 to 1. Then sigma B is equal to 5.67 into 10 raised to minus 8 watt per meter square into Kelvin raised to 4. This is known as the Boltzmann constant. Then the second one is Kirchhoff's law. It states that the emissivity is equal to alpha when the body remains in the thermal equilibrium with its surrounding. Then the third one is the irradiation. It is the total incident on a surface from all direction per unit time per unit area of surface. Then the fourth one is radiosity J. J is equal to all of the radiant energy leaving a surface per unit time per unit area of surface. Here the equation of J is equal to epsilon plus rho into G. Then Planck's law, d lambda b is equal to 2 pi c square into h lambda raised to minus 5 divided by exponential into ch by lambda kt minus 1. This equation is very helpful in the examination. Then fifth one is absorptivity. It is the fraction of incident radiation absorbed and reflexivity is equal to rho. Then third one is in the transmissivity, the fraction of incident radiation transmitted. Then the note of this table is very helpful in the examination. For black body, alpha is equal to 1, rho is equal to 0 and tau is equal to 0. Epsilon is equal to 1. Similarly for the opaque body, tau is equal to 0, alpha plus rho is equal to 1. Then for white body, rho is equal to 1, alpha, epsilon and tau is equal to 0. Then for grey body, emissivity is between 0 to 1 and tau is equal to 0. Then after heat exchanger for non-black bodies, first one is infinite parallel planes. Then Q12 is equal to sigma into T1 raised to 4 minus T2 raised to 4 divided by 1 upon epsilon 1 plus 1 upon epsilon 2 minus 1. The value of Q12 will be in watt per meter square. Then here this equation is for the net radiation heat exchanger. Then if a surface is black, then Q12 is equal to sigma into T1 raised to 4 minus T2 raised to 4. Here epsilon is equal to 1 and alpha is equal to 1. Then for equivalent emissivity, epsilon bar is equal to 1 divided by 1 upon epsilon 1 plus 1 upon epsilon 2 minus 1. Then for infinite long concentric cylinder, let consider two cylinders as shown in the figure. Then A1 into F12 is equal to A2 into F21. Here F12 is equal to 1 and F21 plus F22 is equal to 1. Then F21 is equal to A1 by A2. From this concept also the questions were asked so many times in the examination. Just you have to remember one thing, that if a closed cylinder is outside than that of the other cylinder, then for inside cylinder the value of F12 will be 1. Then Q12 is equal to A1 into sigma into T1 raised to 4 minus T2 raised to 4 divided by 1 upon epsilon 1 plus A1 by A2 into 1 upon epsilon 2 minus 1. then T proportional to root x, and K is equal to K naught into 1 plus AT. Here for A greater than 0, temperature will increase. For A less than 0, temperature will increase but K will decrease. Then radiation shield concept. For that, Q12 of shield is equal to A into sigma into T1 raised to 4 minus T2 raised to 4 divided by 1 upon epsilon 1 plus 1 upon epsilon 2 minus 1 plus summation of J is equal to 1 to n into 1 upon epsilon J1 plus 1 upon epsilon J2 minus 1. Here if the shields have same epsilon, then in the first case, if one shield is used, then 50% reduction will be there. Then if 9 shield is used, then 90% reduction is there. Then after for monochromatic emissive power of black body, equation will be EB lambda is equal to C1 lambda raised to minus 5 divided by E raised to C2 by lambda T minus 1. Here the value of C1 and C2 also you have to remember. Then Wein's displacement law, lambda max into T is equal to constant. This is also important for the examination. Then EB is equal to sigma B into epsilon into A into T raised to 4. Then after 6th one is the Lambert's cosine law, d theta is equal to En into cos theta. Here note that solid angle by sphere theta is equal to 4 pi and for hemisphere theta is equal to 2 pi. Then emissive power of black body is pi times then the intensity of radiation, EB is equal to pi into I. Then the last topic of heat transfer is shape factor, the fraction of radiative energy that is diffused from one surface element and strikes the other surface directly with no intervening reflection. Here F12 is equal to fraction of energy. Here the equation of F12 is equal to Q dot 12 divided by Q dot 1, and similarly for F21 Q dot 21 divided by Q dot 2. Then here note that Fmn, which is shape factor, only depends on the geometry, and 0 less than or equal to Fmn less than or equal to 1. Here if the body is enclosed by the other body, then F12 will be 1, which we have discussed earlier. So this is all about the subject of heat transfer, in which we have included all the important formulas of the heat transfer. So for that, the upcoming chart of the theory of machines, please subscribe and press the bell icon, and to like this video as well as share to your other friends who is preparing for the examination. Thank you so much.